Sorry for the delay.
Did you go to the wrong classroom?
No, I got caught up with something in my office. I went to the wrong classroom, then marked you all as absent. Okay, so we kind of ended before we were able to do some useful things with the scanner, that being Flex. And this is the file that I started working on. And let me see, I only got as far as there were definitions. So every Flex file you'll create has a .l extension. And it's divided into 3 parts. Each of those parts is separated by a pair of percent signs. The top part being definitions. Those can certainly be things that are specific to C++, and in fact we will do some of that. It also is a place where you'd put directives for the scanner, for Flex, to change Flex's behavior or to set some variables and so forth. So we'll look at that. The part that is going to be tying most closely to what we had done previously, if you recall, we did the work on regular expressions just to get your feet wet. And there will be some of that here, and it will be in, as it's shown here, and I'll illustrate it, but you put some sort of regular expression pattern followed by the action that you want to take should that pattern be matched. And that action will be code. What kind of code do you want to execute? And then after the final part is where you put literal code, and really I'd say that more generically and say whatever you put after that last pair of percent signs is just copied blindly into the file that it generates. Okay. So let's actually look at a bit of an example. If you're putting C++ code in here up top, you can do it by indenting, but I found that I don't get nice syntax highlighting if all I do is indent and start sticking code. So Flex provides a mechanism for embedding code, and it helps, in my case, Vim understand that it is code and that it'll highlight it correctly. And that is with a percent followed by an open curly brace, and then when you're done, a percent followed by a closed curly brace. Okay, so what I want to do here is I want to include IOStream, and then I'm going to use cout, so also using standard cout. In general, we're kind of stepping up our game now, and we want to avoid using namespace standard as kind of bringing in everything from the standard into our current namespace. So let's use it more selectively, as we would as mature programmers. So what's an example of a pattern? I guess I'll leave that comment there. 23. What'll that regular expression find?
The literal text.
The literal 2 and 3, yes. So if it finds a 2 and a 3, what I want to do is I want to say I guess I don't need that, cout 2, 3. Next, if I find any other character, I'll just say about found one. Let's actually just run with that much of it. Let me go ahead and okay. That is saved. And then I have the main function, which right now isn't doing anything. And you'll note that when you run flex, what it generates is this C file. I think I did this when I didn't have anything in there at all, and it was, what, just shy of a couple thousand lines. Yeah, around 1,700 lines. So you'll see here that that's what it's doing, is anything after that final pair of percent signs literally just ends up, whatever you write there ends up at the bottom of this file that it generates. Okay? And so obviously this is a nice candidate place to put functions that you're going to want to use. That includes right here functions that you may call, you could certainly define down here. Now we're going to be getting, when we get into the project proper, we're going to be dealing with a whole bunch of separate files, and so you may very well just put those definitions in a separate file. All right. Let me change my prompt here. Okay, so we have, let me bring this up. What kind of error do we have here? Linker error. And what it's complaining about is that there is a call to YY but we don't have any function definition for YY Now, it turns out that the way Flex works as a scanner is that you can feed it multiple files. And what it's going to do is it's basically going to scan through the first file, and then it's going to call YY and depending on what YY returns, it either will or will not go on to the second file or the subsequent file. Okay? We're not concerned about that. We're not trying to scan a whole bunch of files. All we have is first.l, and in fact, when we get to our project, all we're going to have is gpl.l. It's just simply not relevant to us that there would be a whole bunch of flex files that we need to scan in turn, or even make a decision as to whether or not we scan subsequent files in turn. So what we want to do is go back in here to our definition, and we're going to provide a directive to Flex saying no YY or excuse me, option no YY Now it'll stop complaining. And again, note that I had placed that above the first pair of percent signs, designating that it is a Flex configuration option. Now I can go ahead and try compiling it again. What did I do wrong? I still got the error. Did I save my changes? Can't see it. Let's see. Yes, I did save my changes, so why did it complain? I have an incomplete workflow. So, first lesson, never ever forget, after you make a change to the Flex file, you got to run it through Flex again to generate a new C file, right? This is kind of the advanced version of the problem you get with 111 students, where they spend 15 minutes changing their file and they can't figure out why a.out isn't running any different. It's because they forget to compile. All right, so similar idea. So I'll rerun Flex. Now I'll run the compiler. And there's no error at all. Let's run it. Nothing happened. Why did nothing happen?
The program is designed to do nothing.
The program's right. There's a whole bunch of stuff there, but the main function just returns immediately. Right? There's no work being done. So what we have to do is we have to tell our main function that we want to go ahead and scan input. And that is the function for doing that. Okay? So when you run flex, it's basically creating all the code to make YYLEX work correctly. What do I mean by work correctly? Do the things that you did up here, which means it's going to take input, and if it comes across a 2-3, it's going to print out 2-3. If it comes across any other character, it's going to print found one. I'm going to step up what I do here, and rather than doing it in 2 separate steps, I'm going to use a little bash trick. Let me zoom in here, and let me clear the screen. Again, I do have that CTOD type if you wanted to look at your own screen rather than mine. All right, so this is using short circuit logic just as in C++, whereas it will run the first command, flex first.l, and only if that command executed successfully will it do what comes afterwards, which is to compile. If there's a problem in flex, then it won't do the G++ stage. Did I forget to write? I forgot to write. I did forget to write. Now it's just hanging there because it's reading from standard input. So if I say 1, 2, 3, 4, 5, when I'm done, Control D. All right. What if I do this? ABC. One, two, three, four, five, ABC, 6, 7, 8. So what's happening? I didn't get Sesame Street. Why is that?
It reps.
Huh?
It's the one.
Oh, it did get it. Okay.
Why is it finding so many periods? Because it's anything else.
It would find the 1, the 2, or excuse me, it'd find the 1, the 4, the 5.
Oh.
So the 1, the 4, the 5, Sesame Street. Let's find a new line. We'll even add a new line in there. Okay. It can, the order can matter. So as a general rule, what you want to do is you want to go from specific to general. Yeah.
So, it seems that if any the dot is just a general thing, and any more specific rule is override. Not matching the ordering where it is inside the.
Yeah, and right. And it's there are times where you get some ambiguity and the order does matter, but yeah, so it is picking out more general. So what about if I let me get rid of this one. Now let me run it again. Whoops, I didn't do what I wanted to do. 1, 2, 3. Where am I here? All right, so there's the DEF. So if it is not specifically found in the regular expressions, it's just going to be parroted right back out, unaffected. Okay? Yes?
What makes it print 2, 3 rather than digital? When you have 1, 2, 3, 4, 5, instead of doing digital for 2 and 3?
Because of the specificity of the regular expression goes ahead and
Okay.
takes precedent over the general. Yes?
So if we had a rule underneath 2, 3 of just 2, would that override 2, 3? Or would 2, 3 override that because it's first in terms of your ambiguity only thing? Or? Rule
Okay.
On line 14.
The two, let's see what happens now.
Oh.
This makes sense. If I do a 2, 3, there's no ambiguity and it's going to grab the 2, 3. If I do a 2 by itself, then either the 2 by itself or the digit regular expression are able to grab it. And so in that case, the order does matter, because if I do that, let me clear the screen here, 2 will never be matched because 0 through 9 can get it. Now, why do we not have that issue with line 13 with 2, 3? Because it will go ahead and see if the 2, 3 is going to match before it blindly does the digital regular expression. It'll see what's after the 2, essentially. It looks ahead. Yeah.
Is it looking for the longest match?
By default, yes, that is true of regular expressions generally. They always look for the largest match. So when I showed that any text that we have that is not covered in our patterns is just parroted right back out. When we get to actually sending this on to a parser, we do not want anything going on to the parser except the tokens we described. So remember that I had that example, let's see here. Right, where there's this conversion of code to these sets of tokens, and it is the parser that handles the tokens. What we don't want is we don't want any character here not handled. So what if it hit a space or a blank line or something like that, a new line. Right, we saw that new lines don't matter because this kind of thing is going to compile just fine. So if I don't handle new lines specifically, then that new line is going to be passing through our parser, through our scanner, and it would be considered bad form to do that, right? So what we need to do is we need to ignore things like that. Yes?
So this lecture or standard is run before the actual compiler. So the new lines they matter like at least the compiler step or the lecture step.
Well, it all depends on the context of your application, right? In general, if we're thinking C, and this would be true of GPL as well, we want to ignore new lines. So what we would do is basically, we would handle all our specific cases here. Let me go ahead and move this to above there. We handle all of our specific cases, and once we are done with specific cases, then any spaces or new lines that we find, we just simply want to do nothing.
So they won't be echoed out. Is that why we're doing it? So they won't be just put back out in the absence of a
Yes,
factor.
we want our scanner to capture everything. But to put it another way, if you're letting stuff through that you're not handling, then there's a chance that you're not handling things correctly. Right? So the scanner can actually help us out with that. So here we've got a warning saying that a default rule can be matched, default being anything else. So what I can do, I'm not sure what obviously like the letter D would be an example of something not being handled. So that would handle, any other character that comes along, I'm going to do nothing. And now it doesn't complain. Okay, so we want no YY wrap, so we don't get that function defined that handles multiple flex files, and we want to always set the option for no default so that Flex will warn us if we have any characters at all getting through. Now that said, I'm going to be cutting you loose pretty quick to do a little something. Don't do the no default. The default is fine for what we'll be doing. In fact, I think I've stole my thunder. There's a little question posed, and I think that I've pretty much answered it at this point. You are allowed to put these in quotes. What the quotes will do is they will turn off any specific processing. So this means any character. This means a period. Right? Another way of doing it, of course, is with the backslash. But if you just have something here, and in general you don't want, like you may have something like this, rather than finding all the periods and putting backslashes in front of them, you'll find it far more readable just simply to do that. Then those would be considered periods and not random characters, any possible character. Let's take a look at what's actually happening here with the code that's generated. And I want to say that These curly braces are optional. You could leave them off here, but there's a very good reason why you want them. Whoops, default can be matched. Let me throw. All right, so I'm going to take my G++ line and I'm going to say that. Anyone know what the -E option does? Yeah, I'd phrase it as, so the G++ is not necessarily a monolithic executable that you're running, but G++ is managing a workflow, right? G++ is running the preprocessor, then it's running the compiler, and then eventually it's running then it's running the assembler, and then eventually it's running the linker. So the -E means to stop that workflow after the preprocessor. So that'll do preprocessing, yes, which means handling pound include and pound define and stuff like that.
If you don't specify the -E, doesn't it put a whole bunch of other processes or compiler directors and the -E gets rid of them?
Yes, that's correct. So let's just look at it. So if all I'm doing is going through the preprocessor, when I'm done, I should still have C++ code, right? Because no compiling is being done. So let me just call this preprocessed.cpp. And we can definitely see code in there. But what we also see is a whole bunch of this stuff. And as Konstantin said, these are directives that go onto the compiler, and they help the compiler tell you what's wrong with your program when you have errors. For my case, I'm not interested in that in this discussion, so I'm just going to add the -P as well, and that removes those. Now I don't have any of those in there. All right. Let's see, I want to look for cout. So what's happening is once these regular expressions are matched, you're then dumped into a switch statement, right? And if you match the first regular expression, it's going to be case 0, or excuse me, case 1. If you match a second regular expression that you typed in, it's going to match case 2, and that kind of thing. So then the next question is, why is it so important to, what is the utility of having curly braces in a switch statement, in the case of a switch statement? Yes? So what happens once you boil this down is there's a jump that occurs, right? You hit this line of code here, and then it's either going to jump to line 10 or it's going to jump to line 13. And the issue is, actually, let me back up. If I, in a function, or let's just say inside of a function somewhere, or as the else part of an if statement, if I create a variable, when does it go out of scope? Comes in scope at the declaration, point of declaration, right? When does it go out of scope? With the closing curly brace. So if I have an if statement, and then I've got code, and then here I have int x, and then maybe even inside here I have an if statement, curly braces. So x comes into scope at line 25, and it goes out of scope at the closing curly brace of the pair of curly braces that are enclosing it, which in this case would be this pair right here. All right, so it would go out of scope on line 31. So that's the rules of scoping in C and C++, or it is in C++. In C, you have to declare variables at the top of the block. That means, according to those scoping rules, that automatic variable comes into scope at line 11 and goes out of scope at line 16. That's fine. There's no issue with that. The problem is that a switch allows you to jump directly to 13. And now you're able to use a variable while jumping over and not seeing its declaration. Okay, so it's for that reason that you want to put all these in curly braces, because you're going to have an arbitrarily large number of lines of code here, and you may very well create variables and manipulate them. And I can guarantee in GPL you're going to be doing that kind of thing. So you're avoiding those kinds of errors by putting these in curly braces, because you now know that each of these is appearing as the case of a switch statement. Yes?
Can you go back to the error with I think that if you actually compile it with GCC instead of FS, it will give you an error. It will give you a warning. But actually, like, you compile it and it's returning the bad code.
Yeah, but I've got C++ code in there. Yes. All right. So, what I'd like you to do then, again, you don't need the no default for what I'm about to ask you to do, is if we come back to this assignment 3, we did the regular expression stuff in class last time. Now I'd like you to do this right here. So I want you to write a scanner, a flex file, that is going to print out parts of speech, and I don't want you to handle the entire English language because that'd take a while. All I've done is I've provided attached files. There's this input file.txt. And all this is a couple lines of text here. And I'm using that as the motivation for what's being chosen here. So if it's the or the, what you want to do is see out this. Just see out, no spaces, no new lines, just see that out. See out that, I should say. The only trick, it isn't that difficult. The only real trick is that I want you to use only a single regular expression for each part of speech. So quick and brown are both adjectives. You should only have one regular expression to grab both of those, and if you find either of those, then you print out that. Okay? Does this make sense what I'm asking? So the output, when you run you'll run flex, you'll compile it, and then when you run it, it'll be something like, oops, what am I doing there? Now I've done it. I don't know where I am. Well, all I really screwed up something. All right. Oh, there we go. Although, that's still working. When you run it, you would just simply redirect the input file to it. So rather than typing in the stuff, you do that. And then you should get the output that you see here at the bottom of the page. So this is shown as a discrete assignment that you turn in. Yeah, go ahead and turn it in, but I'd like to get it done today in class. So any questions on what I'm asking you to do? Yeah, you have half an hour. I don't think it'll take more than half an hour. Also, do not use OS 10, your Mac, does have Flex and Bison. Don't make the mistake of accidentally working on this there, because the Flex and Bison variants on OS 10 are not the same as on Linux, and you're going to get weird behavior. I don't know if you get weird behavior today, but if you are using it now, you'll definitely eventually hit weird behavior that no other people are going to have problems with.
Flex file?
From last time, if you grab the notes from last time, they're posted on the course shell.